Hello friends! Today we're learning part 2 of the binomial theorem. We're actually going to see what the binomial theorem is, and we're going to use it. And this will be our last lesson from chapter 10. We're going to skip a few of the parts on probability so that we can just, make it through the year the best we can. So let's start by looking at one of the problems we did last time when we started talking about the binomial theorem. We started talking about expanding binomials. And what we did was we used the numbers from Pascal's triangle to give us the coefficients. And so in the fourth row of Pascal's triangle, we would have the numbers 1, 4, 6, 4, and 1. And then we would have the powers of a descending. So we have a to the fourth power, a to the third power, a to the second power, a to the first power, and then a to the 0 power. And we would have the powers of b ascending, so we start with b to the 0, and then we have b to the first, and we have b to the second, b to the third, and b to the fourth. And then all these terms are added together. So remember those patterns from last time, and we also had the pattern that if it was minus instead of plus, the signs would alternate. You'd see a negative sign as your first sign, and then you see plus, minus, and so on. Okay, so of course we don't need to write the 1 in front of the first term or the last term. But the other thing we saw last time was that these numbers from Pascal's triangle are also combinations. And so the 1 in the first position is 4, choose 0. So we have 4, choose 0 times a to the fourth. And the 4 in the next position is 4, choose 1. 4, choose 1, a cubed, b to the first. I'm going to write b to the 0 on the first term. And then the next one is 4, choose 2, a squared, b squared. And the next one is 4, choose 3, a to the first, b to the third. And then the next one is 4, choose 4, a to the 0, b to the fourth. So we're going to generalize this in just a moment. Notice that the first term has a choose 0 in it. So let's say you wanted the 29th term, it would actually have a choose 28 in it. Or if you wanted the 77th term, it would have a choose 76 in it because the first term has 0, so we're off by 1 each time. Another thing to notice is that the power on b is always the value of r. So b to the first, 4, choose 1. b to the second, 4, choose 2, etc. Those numbers are always the same. b to the r, 4, choose r, or whatever it is, n, choose r. And also notice that the powers on a and b add to 4 in this case. 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, and so on. So those numbers are going to add to n, where you're raising your binomial to the nth power. So putting all those patterns together gives us the binomial theorem. Okay, I didn't type it in, I just took a picture of it and took a picture of the picture. And so that's why it's looking kind of swoopy, because my book wasn't flat. So what we see here is if we want to find a plus b to the n, we have all of our combinations, n choose 0, n choose 1, n choose 2, dot, 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 all the way over to n choose n. And then the powers on a are going down 1 each time, starting with a to the n, then a to the n minus 1, a to the n minus 2, etc., all the way down to a to the 0. And the powers on b are going up 1 each time, b to the 0, b to the first, b to the second, all the way up to b to the n. Okay, and we're adding all these terms. So all those patterns are exactly like the patterns we looked at last time. We're just putting it all in general notation here, so we see lots of letters and numbers. It also says, notice that each term in the expansion has the form n choose r times a to the n minus r times b to the r. Again, like I was pointing out on the last slide, b is to the r power, so you have choose r in your combination. So if you were doing the exact same problem we started with and it said use the binomial theorem to expand, what they're saying is they want you to recognize that you're using combinations. So rather than just writing the numbers from Pascal's triangle, 1, 4, 6, 4, 1, you start by writing the combination. So we have 4, choose 0, a to the 4th, b to the 0. 4, choose 1, a to the 3rd, b to the 1st. 4, choose 2, a to the 2nd, b to the 2nd. 4, choose 3, a to the 1st, b to the 3rd. And 4, choose 4, b to the 4th. A was to the 0. Okay? Personally, just between you and me, maybe we can keep this secret. I don't do it this way. I just use Pascal's triangle. But I just want you to know what the book means when they say do it this way as opposed to using Pascal's triangle, because we end up with the same thing, but the way we get there maybe is slightly different. Okay, I also want to remind you that there are different notations out there for the combinations, so sometimes you might see something like this. With parentheses around the 4 and the 0, that means the same thing as 4, choose 0. So I could see why someone would want to write it this way, because it feels like it's taking up a little bit less space, just writing those numbers vertically and not putting the C in there. The way I showed you originally is the way that it's written in our book. But I'm kind of a fan of this now that I try it. I think I see good reason for it. Okay, sorry that went uphill a bit. Okay, let's move on and do a couple of examples. Use the binomial theorem to expand a minus 2b squared to the 3rd power. Okay, so the coefficients are going to be the combinations from row 3, or 3 choose 0, 3 choose 1, 3 choose 2, etc. Row 3 of Pascal's triangle numbers. And so if we write it out using the binomial theorem, we have 3 choose 0 times a to the 3rd. And then we have minus, and then we have 3 choose 1. And then we have a squared, and then we have 2b squared, plus, and then we have 3 choose 2, and then we have a to the 1st, and then we have 2b squared to the 2nd, and then we have minus, and then we have 3 choose 3, and then we have a to the 0, and then we have, oops, okay, I'll go back and fix that in a second, and then we have 2b squared to the 3rd. You see my oops? I put an extra minus sign in there. Okay, all better. Now, let's go ahead and simplify this. So 3 choose 0 is 1. We have 1a cubed. 3 choose 1 is 3. We also have the 2. So we have 3 times 2. So we have minus 6, a squared, b squared, plus 3 choose 2 is also 3 times the 2 squared. So 3 times 4 gives us 12. So we have 12a b to the 4th minus, and 3 choose 3 is 1, and then we have 2 cubed, so 1 times 8. So we have 8 b to the 6th power. Okay? And the last few examples we do are not actually writing the entire expansion. We're just talking about a single term, either giving the whole term or just giving the coefficient on the term. So number 3, find the coefficient of x to the 4th in the expansion of 3x plus 2 to the 10th. Okay, so let's piece this together. So we're going to have 10 choose something, and then we're going to have 3x to the something and 2 to the something. And we know that it's going to have an x to the 4th in it, so that tells us that it's going to be 3x to the 4th. We're just using the clues and letting the clues help us make another step in the direction of figuring this out. Now we know that the two exponents have to add to what? To 10, that's right. And so we already have a 4, so the other one's going to be a 6. And we also know that if there's a 6 here, there's a 6 here. So that number is also a 6. So now we have everything filled in, but we need to simplify it to find the coefficient. So the first thing we find is 10 choose 6. Let's see here, get my calculator. I have alpha window, Number 8 is my combination shortcut. 10, choose 6 is 210. But 210 is not the answer to the question because we're going to get more coefficient from the 3 to the 4th and from the 2 to the 6th. So we have 210 times 3 to the 4th is 81, and then x to the 4th, times 2 to the 6th, which is what? 64? So we have 210 times 81 times 64, and that is 1,088,640. Now if we're writing the whole term, it would be 1,088,640 x to the 4th, but it said, what's the coefficient? So we're just answering with that part of the term. Okay, number 4. Find the coefficient of x to the 5th in the expansion of x minus 3 to the 7th. Very similar problem. We're just going to have to deal with the minus. And typically what we do is we use the pattern of alternating signs, and we just have 3 raised to each power as we go. But that's not going to work so well in this problem. So what I'm going to do is think of this as x plus -3 to the 7th. Okay, the coefficient of x to the 5th. So we know we're going to have 7 choose something, and we know we're going to have x to the 5th, and then we're going to have -3 to the something. So we know these two exponents have to add to 7, so we have a 2 as our second exponent, and that means it's 7 choose 2. Okay, so now we find 7 choose 2. Using the calculator, 7 choose 2 is 21. 21 times x to the 5th. The reason I left the negative with the 3 is because I wanted to know whether the coefficient is going to turn out positive or negative without having to really figure out where this falls in the alternating pattern. And so I figured if I just raise my negative to an even power, it'll be positive, and if I raise my negative to an odd power, it will be negative. So here we are raising our negative number to an even power, so we get positive 9. And then we multiply the coefficients, 21 times 9, and that is 189. So the whole term would be 189x to the 5th, but the coefficient is 189. Okay, for the next example, I decided let's go ahead and find the entire term. Find the 8th term in the expansion of 2a plus b to the 13th. So let's see, we know that it's going to be 13 choose something. And remember that if it was the first term, it would be choose 0. So if it's the 8th term, it's going to be choose 7. We're off by 1. And then we're going to have 2a to some power, and then we're going to have b to some power. Do you know what b is going to be raised to? That's right, to the 7th power, because the 7 here has to match with the 7 here. So do you know what 2a is going to be raised to? That's right, the 6th, because the 2 powers have to add to 13. Okay, let's work this out. So we need to find 13 choose 7. 13 choose 7 is 1716. And now we need to raise 2 to the 6th power, and that is 64. And then we have a to the 6th as well, and then we have b to the 7th. So let's multiply 1716 and 64 together. And we have 109,824, a to the 6th power, b to the 7th power. And that's the entire term. Okay, that wraps up our study of the binomial theorem. Here's your homework. Check answers, ask questions, send pictures. Thanks, everybody. You're doing great.